All right, welcome to The Explainer. Today, we are going to trace the incredible evolution of the diesel engine. Seriously, it's a journey that took it from being the grimiest, hardest-working engine on the planet to a super-refined, high-performance powerhouse.
You know, the story of the diesel has always been a story of two extremes, right? On one hand, you've got this incredible promise, amazing fuel efficiency and just tons of torque. I mean, that raw pulling power. But on the other side, you had all those rough edges, the clatter, the shaking, and of course, that embarrassing cloud of thick black smoke.
So way back in the beginning, the diesel engine found its perfect home. And it wasn't in quiet family cars. Nope. It was in the world of heavy-duty trucks, whereas raw power was exactly what you wanted, and nobody really cared about the noise and the smoke.
You know, for early truck companies like MAN and Benz, the math was super simple. A diesel's raw power and its fuel-sipping nature meant you could haul more stuff for longer distances and spend less money doing it. This wasn't about being smooth or quiet. This was a straight-up business decision, and it made all the sense in the world.
And 1924, well, that was the big one. When MAN started rolling these things off the assembly line, they weren't just building trucks. They basically kicked off the diesel engine's total takeover of the highways, a reign that's lasted for pretty much a century.
But, getting from that starting point to being the king of the road, that took more than just a good idea. It took decades of some seriously clever engineering, with each invention kind of stacking on top of the one before it.
And this timeline, it just lays it all out so perfectly. It all starts with mass production. Then boom, 1938, the turbo shows up. And what a revolutionary idea, right? Let's just cram more air in there to get more power. But of course, that creates a new problem. All that compressed air is hot. So in 44, the intercooler is invented to cool it down. You can just see the pattern, right? One solution leads to the next challenge, and engineers just kept knocking them down.
Okay, so the turbocharger, its real genius is that it's basically the ultimate recycling program for an engine. It takes the engine's own hot, useless exhaust gas and uses that energy to spin a turbine. And that turbine's job? To cram way more air back into the cylinders. More air means a bigger boom, more power, all from the exact same size engine. It's brilliant.
Okay, so this brings us to the biggest challenge of them all. The diesel was the undisputed king of the highway, but could you really take this noisy, smoky, shaky workhorse and somehow make it civilized enough to put in a family car?
And this quote from a Toyota paper just nails it. The problem was so clear. I mean, who cares how great your gas mileage is if your car sounds like a tractor and leaves a puff of black smoke every time you pull away from a stoplight? That whole package, the noise, the vibration, the harshness, and that smoke, those were absolute deal breakers for your average car buyer.
And wow, this image, it just says it all, doesn't it? This was the public image of diesel for decades. That thick cloud of soot wasn't just some little quirk, it was an embarrassing and very public sign of a dirty, inefficient burn. There's just no way you could sell that to a family looking for a new car. Now, don't get me wrong, engineers definitely tried to fix this. They messed around with different systems all through the 80s, trying things like indirect injection and then direct injection. But honestly, these early systems were just too clunky, way too loud, and way too dirty. The main problems just weren't going away.
And then in the 1990s, something revolutionary happened. A brand new fuel system came along that was about to change the entire game. It was called Common Rail. And believe me, this was the breakthrough everyone was desperately waiting for.
So the fundamental question was this: how in the world do you tame that violent, raw explosion that happens inside a diesel engine? And the answer wasn't to make the explosion weaker. No, not at all. It was to control it with this insane, almost microscopic level of precision. So here's the magic trick behind it all. Instead of some old mechanical pump, a common rail system uses a pump to build up insane pressure, like over 20,000 psi. To put that in perspective, that's hundreds of times the pressure in your car's tires. All that fuel is held at constant pressure in a tube, the common rail. And from there, super-fast computer-controlled injectors fire these tiny, perfectly timed sprays of fuel. Suddenly, engineers had the pinpoint control they had only dreamed about before.
And just look at this. You can literally see the difference. On the left, that's the old way. See that messy, yellow, sooty flame? That yellow color? That is burning soot. You're watching pollution being made. And on the right, with high-pressure common rail, the flame is way cleaner, almost invisible. It's like you're watching the soot get erased from the process right before it even forms.
And of course, the data backs up exactly what we're seeing. I mean, look at this chart. It's incredible.
As you jack up that fuel pressure from low to medium to high, the amount of smoke just falls off a cliff. It drops by more than 95%, down to almost nothing. Just wow.
And that, right there, was the revolution. Common Rail finally made the modern, clean, quiet, and powerful diesel car a real thing. For the very first time, you could have an engine that was just as smooth as a gasoline one, but you got to keep all those amazing diesel benefits, like all that torque and incredible fuel economy.
So, from this moment on, with those huge fundamental problems finally solved, engineers started taking this amazing new diesel tech and tweaking it for two very, very different purposes.
The technology basically split into two different paths. On one side, you had this all-out push for pure performance. They called it engine downsizing, which was all about squeezing every last drop of power out of a smaller engine. And on the other side, the goal was totally different: make a really balanced, affordable engine that everybody could buy.
Okay, so these downsized engines, these are the absolute beasts of performance. We're talking engines with 2, sometimes even 3 turbochargers and injection pressures just pushed to the absolute breaking point. The whole goal is what's called power density, getting V8 power out of a V6, basically. But yeah, all that cool, cutting-edge tech, it comes with a bigger price tag.
Now, the cost-effective approach is a different story. It's all about bringing those core diesel benefits, that awesome efficiency and torque, to the cars that most of us drive every day. It's this really smart balance of performance and price, which is just perfect for your mainstream family car or daily commuter.
And you know, this split is really the ultimate sign that a technology has truly grown up. It got so flexible that it could be tailored for completely different customers, from people who wanted a high-performance sports sedan to people who just needed a practical family wagon.
Which, of course, brings us to the really big question for today. After this incredible 100-year journey of innovation in a world that is moving so quickly towards electric cars, where does the diesel engine even go from here? I mean, after a century of evolution, from that simple, clunky workhorse to a super sophisticated, computer-controlled powerhouse, you just have to ask, right? Is this the end of the road? Or is this engine, this icon of power and